Let's do some examples together of predicting products for precipitation reactions. To begin with, remember that in a precipitation reaction, all you're doing is combining some reactants together and then noticing that a solid is typically formed. And that solid is formed because of solubility rules. And so we're going to discuss those solubility rules today in this video. But for the most part, you've got cations and anions. They're ionic compounds, and so when they dissolve, and they're going to be dissolved in water or something similar, our solubility rules are going to be with water. They create a whole bunch of ions that can now mix and form into compounds with the other chemical that was mixed together. And so when they do that, if they form a compound that is not soluble, then they will come out of the solution into a precipitant. And so these are all the parts that work together to form a precipitation reaction, is understanding the process that goes from the mixing of two chemicals to the formation of a solid product. And do remember that there are also spectator ions that are sometimes involved, and so that is the pair, if you will, of the two ions that form the solid product. And so they are not included in the net ionic reaction, but they are vital to the creation of the balanced formula equation. Let's start out with reacting silver chloride with silver nitrate. The very first step in predicting the products of this type of reaction is first checking to see whether each of our reactants is soluble. So meaning, can we write it like this, where silver chloride's aqueous and silver nitrate's aqueous? We absolutely can, but how do we know that? So in our textbook, we have table 4.1. And in this table, it tells you the solubility of salts in water based on these simple rules. And so read through these, make sure you understand what each one is saying. And then this is what we will use to predict whether or not our different salts that are formed are going to be soluble and therefore would have an AQ after it for aqueous, or whether or not it's solid S after it. So our first compound is silver nitrate. So the first rule says most nitrate salts are soluble. So if you look at your chemical formula and you notice that you have a nitrate, you can assume that that compound is aqueous, just like we have done here. Our next compound is sodium chloride. So rule 3 says most chlorides are soluble, with a few exceptions. Sodium is not any of the 3 exceptions listed, so therefore we can assume that sodium chloride, since it has a chloride salt in it, it is going to be soluble, and it's going to be NaCl with an aqueous symbol after it. So now how do we predict products? So step 1 is breaking each of the reactants into its ionic parts. So you should have known that sodium is +1, chlorine is -1, silver is +1, and nitrate is going to be negative charge. Silver is in the middle of the periodic table in the transition metals, but it's a type 1 ion. And if you uncross those charges in silver nitrate, you'll see that it's silver +1. All right, so now once you have done that, now you're going to just simply react each positive with the negative of the other compound and vice versa. And so sodium's reacting with nitrate in this case, and silver is going to react with chlorine. Basically what's happening is when you throw two aqueous solutions together, they're going to start to disassociate into their components, their ions. But if a sodium refines a chlorine in solution, it doesn't matter because they're going to just break right back apart. But if sodium finds something that makes it insoluble, it's going to stay stuck together, and that's when you get the precipitant happening. So yes, sodium will find anything that's negatively charged in solution. And so for this case, all we're doing is saying, hey, if sodium mixes with nitrate, is that going to be a solid? Or is it the opposite? When silver reacts with chlorine, is that insoluble? And so that's all you're doing. So in order to do this, I did this little rainbow pattern where I just simply react each positive with the negative of the other compound. And so in this case, when sodium and nitrate mix together, we're going to determine the products, which is going to be sodium nitrate. Remember, always write the cation first and then the anion. Next, we have silver reacting with chlorine, and so we produce silver chloride, AgCl. Now the next step is see if our products are soluble. So we go back to our solubility table and we're asking, okay, which of these rules applies to each of our compounds? So sodium nitrate is going to be soluble because of the first rule. It's got a nitrate in it, so it's soluble. But what about silver chloride? Look at Rule 3. Rule 3 says most chlorides are soluble, so we would think it's soluble. But there are notable exceptions, and the exception is one of them is silver. So since silver chloride has silver in it, then according to this rule, it's going to be an exception to solubility, meaning it's going to be soluble. It's going to drop out of solution. So based on these solubility rules, we know that silver chloride is going to be insoluble and it is a solid. So now the final step is we need to learn how to write formula, complete ionic, and net ionic equations. And so for this step, we're going to just simply write the full balanced equation with all states shown. So we have our reactants, and then we have our products, and we have to note that they're aqueous with the exception of silver chloride, and that's our solid. And that's what we're trying to figure out because this is a precipitation reaction. Step 2 is writing a complete ionic equation. So in this case, you're going to write all soluble compounds in ionic form with charges denoting how many numbers of them you have, but then all insoluble compounds, do not break those apart. Keep them together as a molecule. So that will look like this, where you have all your ionic species written, except for silver chloride. So silver chloride is written together as a solid. So everything that's denoted as aqueous needs to be broken apart into its components, its different ions. All right, then for the net ionic equation, it's the same as the complete ionic equation, except you're going to go through and put a giant X through anything that is a spectator ion. So notice in this case, sodium is on both sides and nitrate is in both sides. So we cross through those, leaving us with silver plus chlorine yields silver chloride. And that's all the steps to calculate and figure out what is our final equations. All right, so let's do another one for practice. We need to write the formula, complete ionic, and net ionic again. But this is our reaction. Our reaction is calcium chloride mixed with sodium carbonate. So the first thing I want you to do is stop your video and try and write the molecules that correlate with calcium chloride and sodium carbonate. You should have gotten CaCl2 because calcium is +2, chlorine is -1. Sodium carbonate, sodium is +1, carbonate is 2-, so that forms these two compounds that you see here. Now we need to follow the same steps that we outlined for the previous molecules. So first off, we got to make sure are both of these soluble. And if it is soluble, we're going to break it into its ionic parts. So that's the first step. So calcium chloride, is it soluble? Well, if you look here at rule number 3, it says most chlorides are soluble. Calcium is not one of the exceptions, so calcium chloride is soluble. Now, what about sodium carbonate? Look at rule 6. Rule 6 says most carbonates are only slightly soluble. Another way of saying that is they're insoluble. Okay, you'll always get some form of precipitant. So you may think, oh, it's got carbonate. That is going to therefore be your solid. It says, except for those containing the cations in Rule 2. The Rule 2 says if it has sodium in it, then it's going to be soluble. So in this case, sodium mixed with carbonate is in fact soluble. So both of these reactants are aqueous. So now, let's go ahead and break them apart into their individual ions, just as you have seen here. So we've broken them apart, and now we need to determine the products. So this is where you mix your positives and your negatives, and you form new compounds. Then we check and see if those new compounds are going to be soluble. And I do recommend stopping the video at any point. Make sure you know, how did you predict the compounds? You remember just crossing those charges. So now let's check and see if these products are soluble. So we've got sodium chloride as the first one. So if we look at Rule 3, it says most chloride salts are soluble. So sodium chloride is soluble. Now what about calcium carbonate? Look at Rule 6. Carbonate salts are only slightly soluble, except for if they contain a cation from Rule 2. Calcium is not listed in Rule 2, so therefore calcium carbonate is only slightly soluble. Another way of saying that is it will form a precipitant. And so we've got a solid here. And then the very last step is just simply completing all of our final equations. We've done all the hard work. So our formula equation should look like this. Calcium chloride plus sodium carbonate yields sodium chloride plus calcium carbonate. We have to balance it though. So notice in order to balance this, I had to place a 2 in front of my sodium chloride. Calcium carbonate has an S, everything else is aqueous. You do need to start putting these aqueous and the solids in here as well and kind of get used to it. The other two options are L for liquid and G for gas. Now your complete ionic equation. Turn everything into ions, show me all of the ionic forms, but then make sure you leave your calcium carbonate grouped together because it is soluble. Sorry, it is a solid. It is not soluble. All right, so what you've seen here on the screen is us doing this. And so you can see that for like chlorine, there's 2 of them. And so we'd put a 2 in front of them just to show that 2 ions of chlorine would be generated from calcium chloride. And then for your net ionic equation, now we're going to just remove all of our spectator ions. So we can remove our sodiums and remove our chlorines. And that leaves us with calcium plus carbonate yields calcium carbonate. And so with all of these equations, yes, your formula equation is probably the one you're going to use the most, but understanding how you get there is vital in working a whole lot of chemistry problems. And so with that, from this video, you should have a take home of how do I predict solubility rules. How do I use the solubility rules in order to predict the products of a precipitation reaction?